In this video, we are going to learn how we can create some 3D shapes. So let's start by typing box to create a center-based box. Here we can see that both plane and geometry appear with this command. Our intention to see here is first to show you how we are creating the geometry. Now let's turn off the command and preview only the geometry. Now let's type, for example, a 15 to create a number slider to be able to play with the size of the rectangle when we change XYZ components. Here we can see that our base point is the C-plane, so our box is shaping basically around here. Same way, we can create spheres based on the C-plane again. If we connect our geometry to the sphere, we can see the result better and we can change the radius of the sphere by connecting it to a number slider again. So from here, we are going to learn how we can extrude some basic shapes that we have. We can just create a rectangle to make a point-based rectangle, and we can just first create our vectors to be the basis of the points. For that, I'm copying and pasting our number sliders to ease the process. So we are just working on the X and Y components and change the numbers between them. Only that Z component should be 0 in this case. Here we have our points right now. And we see our geometry is shaped as a rectangle. So let's type right now box again and select rectangle-based box. Here the extrusion is already defined for the Z-axis. For that, we can just work on the height and measure. So let's copy and paste the same script. I want to show you another way that is useful when we design more customized shapes. So I wanted to create a line and copy that line on some other location because I want to loft these both lines to understand the differences between basic and customized shapes. So we will use the lofted shape to create a 3D extrusion, which we can reshape and change its form by using 2-point-based parameters. So I type a command called extrude. Here we need to type unit Z. And I'm copying the number slider again to be able to play with the heights. So our height is based on the unit Z. I also want to show you another thing. Our shape can be also in an inclined form. So for that, I just change the height of this line. That connects to the lofted shape. And here we see that when I extrude the shape, it's extruded on the Z-axis defined on the C-plane in Rhino. It's not actually extruded on the Z-axis of the inclined object that we created. For that, I want to show you how we can manage these differences. Here I'm typing dplane to create deconstruct plane command. Then I need to use amplitude command to take the Z component as the output. After that, I need to use mass addition command to connect it to a number slider as an extrusion basis. So from here, we now have our vector based on the Z unit of the object. Let's connect this vector to the extrusion command. From here, we can see the differences between two different Z-axes. One is based on our shape, the other is given by the program itself. And now we see that the Z unit of the plane is originally flipped to the negative axis. We can fix it by typing negative and connecting that to the vector and then the extrusion command. This is all about it for now.